Okay, so here we've got a differentiation question. We've got the function of x equals x cubed, add 48 over x, where x can't be 0. So the first thing it wants us to do is calculate f of 2. Alright, so part A, f of 2 is what we get when we do 2 to the power of 3, add, sorry, I've forgotten what it was, 48 over x. So add 48 over 2. So I can do this one hopefully without a calculator. 2 cubed is 8 and that over 2 is 24. So we're going to get 32. Part B. Sketch the graph of the function f of x from x being from negative 5 to 5 and y being negative 200 to 200. So let's get the calculator to sketch it and then we'll just kind of copy what we've got, I guess. So we've got x to the power of 3, add 48 divided by x, and let's go to the window and set it up the same. So we want the minimum to go from negative 5 up to 5. And then the y values from negative 200 up to 200. I just changed the y scale to 10 so looks a bit nicer, and let's have a look. Alright, so it looks a bit like that, and we need to show that sketch. Alright, so part B just needs to be a rough sketch. We should label x, we should label y, and we should just show that basically it kind of comes in like this and then goes like that, and then this one comes down like that and then goes away like this. Alright, so it's showing we've got this asymptote at when x equals 0. It can't possibly be, and these lines basically, that's going to carry on getting closer and closer, that's going to carry on just getting closer and closer to that line, and that's going to carry on in that direction. Alright, next bit. So we've sketched the graph, find f dash of x. Should be able to do that. Okay, extend the page a little. Part C. Let's just write f of x out again so we can remember what it was. F of x equals x cubed, add 48 over x. I'm actually going to write that out again before I differentiate it. So just write it out a second time, but this time divided by x is the same as times x to the negative 1. So when I come to differentiate f dash x, so remember this is still fx, I haven't differentiated yet. But then when I differentiate, I'm going to get 3x squared, 3 times 1, and then the power of x goes down 1. And here I'm going to get negative 1 times 48, and then the power of x is going to go down 1 again. I'm going to write that out a second time. So this is still f dash x, I'm not differentiating again, I'm just writing it out. So I can show that I know that x to the power of negative 2 is the same as divided by x squared. Alright. What's next? Find f dash of 2. Alright. Oh. Extend the page a little bit. So D. F dash of 2. We're just going to substitute 2 in here. Okay, and this really is the advantage of actually doing this. You can see what's happening when you substitute. All right, so 2 squared is 4, so 3 times 4 is 12, and then take away 48 divided by 4 is also 12. Okay, so f dash of 2 is 0. Of course, you can put all that in your calculator and get the same thing. Alright, next up, write down the coordinates of the local maximum point on graph F. Okay, so let's go over to our calculator. we're going to do the maximum point. Okay, so the minimum point was here when x was 2. I'm guessing the maximum point is going to be when we've got -2, but let's just have a look. We're going to calculate the local maximum, so it's not the maximum of the whole graph, but it is the maximum in this area of the graph. So we'll go a bit under it to the left, enter, and then we'll go again a bit under it to the right, enter, enter again. Okay, and I was right, this is -2 and this is -32. So we write down the coordinates for part E. So it's be getting a bit long, this, isn't it? So E, the coordinates of the maximum are -2, -32. Okay, what do we have to do for part F? Find the range of F. Okay, so the range of F is all the possible Y values that we can have. If we look at our graph over here, or our sketch, it carries on going as far down as we want and as far up as we want, but there's a gap here. And the gap is between -32 and whatever value this is. So let's just work that out, because we haven't got that yet. So calculate, oh, what's happening here? Second, calculate, let's calculate the minimum. Okay, and go along. Okay, left of the minimum. Come up. Right of the minimum. Okay, so when y is 32. So basically the possible y values are anything bigger than 32 and anything less than -32. We need to write that out properly. So the range is when y is bigger than or equal to 32, and when y is less than or equal to -32. Okay, so that's our range. Part G, what's next? Find the gradient of the tangent to the graph at x equals 1. Okay, so let's find the... Oh, let's just go over here. The gradient function we've already worked out, f dash x. So all we need to do is work out f dash of 1. Alright, so f dash of 1 equals, let's just remind what it was. Here we are, so 3x squared. So 3 lots of 1 squared. And then take away 48 divided by 1 squared. Alright, so we're going to get 3 take away 48 equals -45. Parallel to the tangent at x equals 1. We just worked out that when x was equal to 1, the gradient was -45. So basically this is just telling us that there's a second point where the gradient is also -45. Alright, so we're going to find that point. Let's just write this down. Okay, extend the page a little. So, part H. Okay, we also get -45 if we do 3x squared minus 48 over x squared. So that works when x is 1, and it works also for another value. Well, what I'm going to do, I think this is quite tricky to solve. It's not just a normal quadratic. So what I'm going to do is, in my calculator, what I'm going to do is I'm going to put the left hand side, -45, and I'm going to put the right hand side, 3x squared minus 48 over x squared. I'm just going to find where they intersect. So if I look at my graph now, okay, we've got a funny looking graph, but you can see that there's 2 solutions. So this one should be 1. Let's just see if that's true. So calculate and intersect, just to check. If I just say, right, well, this curve and the second curve, where am I on the second curve? Yep, that curve and that curve, enter, guess, enter. Yeah, so it does give me x equals 1. So looks like I'm doing this correctly then. So if I want to calculate the other intersect, so I've got the straight line, I need to make sure I've got, yeah, this curve and guess somewhere near it. Tells me that the other intersection is when x equals -1. And we can make sense of that because 1 squared is 1 and -1 squared is 1, so both, if one of them works, the other one should also work.